Welcome back. We are on chapter 7, rational exponents, radicals and complex numbers, and we will work today on section 7.3, simplifying radical expressions. The first objective number 1, use the product rule for radicals. And let's check what means the product rule. If you have the nth root of A and the nth root of B, which are real numbers, then the product rule says, let's write it down here, the nth root of A times the nth root of B is going to be equal to the nth root of A times B. That is the product rule. Let's apply on a few examples. Use the product rule to multiply, and you have the square root of 3 times the square root of 5 is going to be equal to the square root of 3 times 5 equals the square root of 15. Right? And now we have cube roots of 4 times cube root of 2 is going to be equal to cube root of 4 times 2 equals cube root of 8, and this is equal to 2. And the next example here, moving up, and we have square root of 2 over A times the square root of B over 3. This is equal to square root, and we're going to multiply the fractions. 2 over A, let's do it step by step, times B over 3. And if you remember to multiply two different fractions, we have to multiply the numerators and multiply the denominators, right? So square root 2 times B, 2B, over 3 times A, 3A. That's it. Let's go to the next objective here. Objective number 2, to use quotient rule for radicals. The quotient rule is, it states that if square root, if nth root of A and nth root of B are real numbers, and you're going to have nth root of B different from 0, then the nth root of A over B equals to nth root of A over nth root of B. And this is the quotient rule for radicals. Let's apply to a few examples. We have a few examples here. And the square root of 5 over 16. Square root of 5 over 16, you can simplify. You can use the quotient rule, and you can rewrite the square root of 5 over square root of 16, right? And square root of 5 you cannot simplify. You just repeat, write down again here, square root of 5. But you know that square root of 15 is 4. So this is the result, square root of 5 over 4. Next, square root of 40 over 81. You can rewrite this as square root of 40 over square root of 81. And we can simplify it a little bit more, even further, because we know that 40 is 4 times 10, right? 4 times 10 over square root of 81. We know square root of 81 is 9, right? And this, just doing step by step. On the numerator, we can simplify a little bit more because we can split square root of 4 times the square root of 10 over 9. And this is going to be equal, square root of 4 is 2 over 9 square root of 10. That's the answer. Now, next, we have an example here. Use the quotient rule to simplify. Assume that all variables represent positive real numbers. Okay, so assume all variables positive real numbers. And we have variables only here on letter B. Let's check this first one. First one, letter A. We can simplify writing, splitting this, right? Square root of 3. Cube root of 27 over cube root of 64. Let's split the screen here. Let's split. I'm gonna solve A on this half of the screen. I get this. Okay. And you know that cube root of 27 is 3. 3 times 3, 9, times 3, 3, 27. So cube root of 27 is 3. And cube root of 64 is 4, right? 4 times 4, 16 times 4, 64. So the answer here is going to be 3 over 4. All right, the next one. Now we have fifth root of 7 over 32x to the exponent 5. Let's split this. Let's use the quotient rule. So this is going to be fifth root of 7 over fifth rule of 32 x exponent 5, right? Simplifying a little bit more, we can actually simplify the denominator, right? Because let's just repeat here the numerator, and we can use the first rule that we have seen today. We can split fifth root of 32 times fifth root of x exponent 5. And we know fifth root of 32 is going to be 2, right? 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32. So this is equal to 2 times fifth root of x exponent 5 is x. So this is the simplification, this is the result. That's it for this objective. Let's go ahead and move to the next objective, which is to simplify radicals. We have an example here. Simplifying, letter A, square root of 40. And I'm going to use the quotient rule, the product rule for radicals to simplify this, right? The square root of 4 times 10 is equal to square root of 4 times square root of 10. And we know square root of 4 is 2 times square root of 10. This is the result of that simplification. Now, next one, square root of 300. And 300, we can factor it out, is 100 times 3. Because now we can split, we can use the product rule here, we've seen at the beginning of the class. Square root of 400 times square root of 3. And we know square root of 100 is 10, right? multiplied by square root of 3. So this is the result for that simplification. Next, I think we have a few more examples. Yes, letter C. Actually, here on letter C, we can try, but you're not going to find anything that we can simplify. 3 times 5, square root of 3 times square root of 5. But this actually doesn't help us at all because we don't have a number, an integer, a whole number, anything to substitute here, right? So this is already simplified. This is the simplest way of representing square root of 15. That's it. There's no more simplifications that we can work out. More examples. Simplify each radical. Now we have cube root of 16. Cube root of 16, we know that cube root of 16, we can factor 16 out, and it's going to be 8 times 2, right? 8 times 2. And we can use the product rule here and split cube root of 8 times cube root of 2. Because we know we have a number here for cube root of 8, which is 2, right? 2 is the cube root of 8 times cube root of 2. This is the simplification. Very good. Now letter B. Letter B, we're going to apply quotient rule here. And the cube root of 3 over 64 is cube root of 3, 3, yes, over cube root of 64. Great. Can you simplify a little bit more? I think the answer is yes. So cube root of 3, this is already the simplest way, the simplest numerator that we can have here. But we know that the cube root of 64 is going to be 4. And this is the result, the best simplification that we can have for this radical. More examples. We're going to work out more examples. Simplify each radical. Assume that all variable expressions represent positive numbers. Okay. So the first one we have here x exponent 7. And we can rewrite this as a square root of x exponent 7, right? You can rewrite the square root of x exponent 6 times x. Because we can now write down this like that. Square root of x exponent 6 times square root of x. And this term here, this thing here, we can simplify. Remember, we can rewrite, just to do it step by step, we can rewrite as x exponent 6 over 2, right? This is square root, there's a 2 here, times square root of x. This is equal, let me write down here, equals x cubed times square root of x. That's it. This is the, oops. This is the result of this simplification. Okay. Now the next one. Letter B. Square root of 20 over x exponent 16. Let's work, what we're going to do here, let me just clean this up. Yeah. All right. And we have space now. We can rewrite this as square root of 20 over square root of x exponent 16. Let me do this step by step. Square root 20 is 4 times 5, right? And square root of x exponent 16 we can rewrite as x 16 over 2, right? Oops. Let me adjust this. Over 2. That on the numerator we apply product rule. We rewrite the square root of 4 times square root of 5 over x exponent 8. And we know that square root of 5 is 2. 2 square root of 5 over x exponent 8. This is the result of the simplification. And let me check, I think we have a few more examples. Yeah, simplify each radical. Assume that all variable expressions represent positive numbers. Let's check this one now. Apply product rule here. The cube root of 54 x exponent 6 times y exponent 8. You can rewrite, you can split this, right? And this is cube root of 54 times cube root of x exponent 6 times cube root of y exponent 8. Great. For 54, we can factor 54 and rewrite as 2 times 27, right? Cube root times. We can rewrite this x 6 over 3 times, and we can actually write this as cube root of y exponent 6 times y exponent 2. Simplify even more. Let's simplify a little bit more. And I'm doing this step by step. And when you get some practice, you can do it faster. You can skip some steps. But I'm not skipping steps. I want to show you everything that we are doing. Okay? So we can use product rule here and split this cube root here. Cube root of 2 times cube root of 27 times x 6 divided by 3, 2 times, and we can split this one, cube root of y to the 6th times cube root of y exponent 2. Now let's finish here. Let's repeat this. Is the cube root of 2 times cube root of 27 is going to be 3, right? 3 times 3 times x squared times cube root of y exponent 6 is y exponent 2, and cube root of y exponent 2 we just keep like this. We cannot simplify it anymore. That's it. Just to make it look a bit nicer, let's rearrange it, because we can put together, we can use the product rule to put together this and that one, and we can rewrite this as 3 times x squared times y squared times cube root of 2 times y. And this is the answer that we're looking for. This is the solution. Okay, a little bit squeezed. I'm sorry here because the numbers are squeezed, but I think you can understand. Let's check out more examples. Use the quotient rule to divide, then simplify if possible. Assume that all variables represent positive real numbers. So let's check the first one. Let me split this in two. Okay, and let's work with this first one. Square root of 20. We can simplify, we can factor 20 as 4 times 5 over square root of 5. And then we can split. We can use the product rule on the numerator. Square root of 4 times square root of 5 over square root of 5. And actually we can simplify, and this is equal to square root of 4, which is 2. Right? Simple, easy. Now these have some variables, have some numbers. Maybe it's more work. Let's try. 7 times cube root of 48 times y to the fourth divided by cube root of 2 times y. And the first thing, let's keep the 7 here, times. And we can apply the product rule here on the numerator. Cube root of 48 times, let's apply the product rule, cube root of y, to the fourth. Okay, now divided by cube root of 2 times y. Which we can split as well. Let's split this. Cube root of 2 times cube root of y. Okay. What we will do now to simplify is combine this here using the quotient rule, can you see? And that one as well, we're using quotient rule. So we're gonna have, let me write down here and let me use a different color, blue, equals. Keep the 7 times, using the quotient rule to put this all together. Cube root of 48 over 2, right? Times, and using the quotient rule to put it all together. Cube root of y exponent 4 over y. See? Because this we can simplify. Divide 48 by 2 is going to be 24, right? 24. And we can simplify y exponent 4 divided by y is y exponent 3. So let's rewrite this. So let's use this space here down to complete the calculations. And we're going to have 7 times cube root of 48 divided by 2, 24. And this is cube root times cube root of y cubed. And we can actually simplify a little bit more. We can simplify a little bit further. This is going to be 7 times, because 24 is cube root 3 times 8. 3 times 8 is 24, right? Times, and cube root of y, exponent 3 is y, right? That means this is cube root of 3 times 8 is going to be 7 times cube root of 3 times 2 times, and I'm going to squeeze a little bit here, y. The result here is going to be 7 times 2, 14, times cube root of 3 times y. Okay, I'm sorry because this is a little bit squeezed, and because this is the result of the simplification of that expression right here. Right, moving on. And now we have a new objective, and the objective number 4 is to use the distance and midpoint formulas. By using the Pythagorean theorem, we can derive a formula for finding the distance between 2 points with coordinates x1, y1, and x2, y2. This formula is going to be, let me show here the distance formula equals square root, and I'm going to have x2 minus x1 squared plus y2 minus y1 squared. And you can try to work this out by yourself. Basically, this is an application of the Pythagorean theorem, and if you plot in the xy plane the points x1, y1 and x2, y2, you're going to be able to figure out, you're going to be able to derive this formula of distance. But by now, just get to know the formula, let's know how to apply the formula. Example, find the distance between points, and let's say this is point 1, and this is going to be point number 2. Okay? Distance equals, the formula you're going to apply, again, x2 minus x1 squared plus y2 minus y1 squared. And this is what you're going to do here is just plugging in the numbers. And if this is point 1, this is x1, this is y1. And this is point 2, this is x2, this is y2. Okay? So let's plug in the numbers in the formula. Distance equals square root x2 negative 2 minus x1 minus negative 5 squared plus y2 is going to be 2 minus y1 is 8 squared. Okay? Distance equals square root negative 2 minus negative 5 is plus 5, negative 2 plus 5 is 3, 3 squared is 9, plus 2 minus 8, negative 6 squared, 36. right? Square root of 45, and 45 is 5 times 9. Apply the product rule here to simplify radicals, and you have d equals square root of 9, 3, and square root of 5 is just repeat square root of 5. This is the result. All right, now this is the distance. This is to calculate the distance. Now let's calculate the midpoint. Let's work out the midpoint formula. And the midpoint formula is the following. The midpoint of the line segment whose endpoints are x1 and y1 and x2 and y2 is the point with coordinates. The coordinates are here. X plus x1 plus x2 over 2, and the y coordinate is the y1 plus y2 over 2. This is the midpoint. This is the way to calculate the coordinates of the midpoint. Okay. So on this example, we had to find the midpoint of the line segment that join points P, -5 and 8, and P, -2 and 2. Let's call this P1, point 1, and that one, point 2. That means this first coordinate here is x1, and that is y1, and now here is going to be x2 and y2. Okay? What you have to do here is apply the numbers, plugging the numbers on the formula, and the formula, if you remember, is x1 plus x2 over 2. This is the coordinate x, and the y1 plus y2 over 2. This is coordinate y equals. Let's apply the numbers. Let's plug in the numbers here. x1 -5. X2 -2 plus -2 is -2, right? Over 2. And y1 is 8, y2 is 2 divided by 2. And the midpoint is going to be -5 minus 2, -7. -7 divided by 2. We can write here -3.5. And 8 plus 2, 10 divided by 2, 5. This is the answer. This is going to be the midpoint, the coordinate of the point right in the middle of the point 1 and point 2 here. That's it. This is the end of section 7.3. Thank you very much for watching.